Today's notes are very short. They go along with that worksheet that I just passed out to you. So this says, in yesterday's lesson, we didn't have a lesson yesterday. This lesson actually goes back to last Monday, I think. I gave you a function and a notation, and I told you to write the transformed function. Now I'm going to give you the new and the old function, and we're going to write the equation from it, okay? Okay, so right here, I give you these two functions. There's a dotted line and a solid line. Today, in all of these examples, we're going from dotted to solid. Last week, we went from solid to dotted, so make sure you're paying attention to which one is which. Yeah, I don't know why we changed it, but today it's dotted to solid. So you can look up at the screen or on the paper that I passed out for your notes. So from that dotted line to the solid line, can I have a volunteer please tell me what is one of the transformations or one of the translations that happens from the dotted to the solid? What's one thing that we do? Yes, Galway. Right 3 units. Do we agree with her? Yeah. Is there another one that happens? Up how much? 4 units. Okay, so today we're going to write in words what's happening. So first we would write right 3 units and then up 4 units. And then using our notation, remember we have a times f of x minus h plus k. We're going to need to fill in all of that information. So h is going to be 3, so I'll have f of x minus 3, k is 4, and then plus 4. So that's what we're going to be doing today, is writing these 2 pieces of information. Okay, on the next one. Okay, so again, we're going from dotted to solid. So we're going to describe the transformations, and then we are going to write them in function notation, okay? So on number 1, from the dotted to the solid, can I have a volunteer please tell me what is one thing? Yes. Up 3 units. Do we agree with that? Okay, good. So one of our transformations is up 3 units. Is that it? Oh, and then left 4 units. So I'm going to go up 2, 3, and then left 1, 2, 3, 4. Good. Okay, so how would I write that in my function notation? F of x, then what? Plus 4. Why isn't it minus 4? Yeah, because left, we're going to change the sign, similar to with a factor, okay? And then what about the 3 for going up? Where does that go? Plus 3 at the end. Is that okay? Okay. Now for number 2. What's happening there? Yeah, it's enlarging. It's stretching. How do I know it's a stretch? Okay, it doesn't move left or right or up and down, but it... What's that motion that you're doing with it stretches? It gets taller, maybe. So if I'm looking at this y value, what is my original y value going to be? 2. Okay. And what is my new y value? 4. So yes, like Diego said, it doubles. So we're going to write stretch by how much? Good. And how do I fill that into my function notation? Yes. Yes. 2 f of x, because that stretches our a value, because I'm stretching by a factor of 2, okay? On number 3, what happens? What do I see? What's the transformation? It's a flip, which we're going to call a reflection. Good. And which axis is that across? Good. Reflect across the x-axis. And what else happens? Because that reflection only puts me to about here. What else happens? Which way and how much? Right, how many? Good, right. 4 units. Okay. Is that it? Yes. So, how do I write reflection across the x-axis in function notation? Good. Negative f of x. Is it right 3 or right 4? Yeah, it's right 3, sorry. I miscounted. Yes, 1, 2, 3, perfect. So it's f of x, negative f of x, then what? Is it plus 3, minus 3? Where does it go? Minus 3, is it inside or outside? Good. It's with the x because it's a horizontal. Now on number 4, okay, number 4 looks like there might be a stretch or compression. I don't know though. So I'm going to help you figure out how we can check for that, okay? So number 4, what's the name of that graph? What do we call it? A quadratic or a parabola. So tomorrow we're going to be working with our 6 parent functions. So that's linear, quadratic, square root, cubic, cube root, and absolute value. Okay, so you've seen most of those. I think there's only 2 you haven't yet, so we'll go over them. Quadratic is one of them, and you guys did this last year with a times x minus h squared plus k. For today, you can still write this in function notation. Starting tomorrow, we'll put it back into a quadratic. But let's look at this first, because clearly the solid line has moved somehow from the dotted line, okay? So if I look at the dotted line, which is my original, I have these 2 points. Do you agree? Or really, these 3 points. Remember making a table last year when you were graphing quadratics and stuff? Okay, so these are the 3 main starting points that I like to use. Now, I know that this original has no stretch, no compression, because I'm going to look at the rate of change or the slope from one point to the other. So if I go up 1 and over 1, that means my slope is 1. Do you agree with that? And instead of saying m equals 1 today, and for our purposes, we're saying a equals 1, because that's what tells us our stretch or compression, okay? Now, it looks like the solid line might be stretched or compressed. I'm not too sure, so we're going to check that one. If I go over here and I find 2 points, I went up 1, over 1. Oh, okay, is that stretched or compressed, or is it still the same? It's still the same. It might just look a little bit wider because it's in a different place, but that's not what a stretch or compression would look like. Now, maybe if I went back to my original graph, and I know you're still paying attention, so thank you. If I went back to my original graph, maybe my graph goes through here. Okay, do you see how I drew that blue one in? Okay. Now this is my point. I'm going to go up how many and over how many. How many did I go up in the blue graph? I went up 2 and I went over how many? 1. So that would mean I would have a stretch of 2 over 1, which is 2. Does that make sense? So that's stretched, and if I continued graphing it, yeah, that looks like it's a little bit skinnier, like it's stretched. Now, maybe I have a compression. So what if the graph went through here? I'm going to go up 1 and then over how many? So I'm going to go up 1 over 2, my rise over run. So that's what a compression would look like. Does that make sense? Is that okay? On this one, it doesn't have it. I'm showing it to you because on the next couple of slides, there might be one, and I want you to know what it looks like, okay? So this one has no stretch or compression, but the way we can tell is by checking out the ratio or the rate of change from the rise to the run, okay? So let's come back to this one. So there's no a value. Do I move left or right at all? And do I move up or down at all? Okay, so I'm going to go down 1 unit, and then what else? Down 1 unit and left 3 units. Do we agree with that? Yes or no? Yeah. Okay, so I'm going to write that as f of x, then what? Is it minus 3? Oh, plus 3, and then what? Minus 1, because remember, k stays the same. H is going to be a different sign, similar to our factors. Okay, is that one okay? 3 and 4? Can you try the next 2? So flip it over. You're going to do 5 and 6 for me, please. Okay, here is number 5. Is that what you got? Yes or no? Yes. Okay. Are you done with number 6? You're still working on it? Okay. 6. Okay, this is what we have. It's a stretch by 2. Okay. And just to go back to what I was saying before, because it's dotted to solid, up 1, over 1. Is that okay? And the original. Now, if I went up 1, over 1, is that point on my graph? No, so I'm going to look for another point until it's on my graph. Oh, look, right here. How much did I have to go up? 2 units, and now I go over 1 unit. So that way I know my A is 2. So that tells me I have a stretch. And on here, it might be a little bit difficult to see just because of the way they're graphed. But if I showed you the entire graph, the dotted lines would keep getting wider. And the solid line would too, but at much less of a rate. It would stay pretty steep and pretty skinny like that, pretty narrow. Do you have questions on 5 or on 6? Can we do 7 and 8 then? Okay. If you look at 7 and 8, do you know the name of those graphs? What are they called? That is a reflection on 7, yes, but what is the name of the graph? It is not a quadratic. A quadratic does not have a cusp like that, or a point. It is not a triangle. You probably did it in 8th or 9th grade. It is not a parabola. That's another name for a quadratic. Have you ever seen this? What is that called? Absolute value. That's an absolute value graph. It looks like a V. Okay? And the reason it looks like that is because normally we have a line that goes on forever and ever and ever, right? What does an absolute value do? What happens if a number is inside those vertical bars? Yeah, it makes it positive. No matter what the value is, it makes it positive. So I can't have any of these negative values. Those are undefined. So I'm going to keep going down. Oh, I can't go negative. So I turn and make a V. That's why that's an absolute value graph, okay? We're going to work with that tomorrow. I just was wondering if you guys knew what it was or if you remembered. So we're still going to write in function notation today. Diego told us we have a reflection across the x-axis. Do we agree with that first transformation? Okay. So I'm going to write that one in. And we need to see, is there anything else? Okay, because that only puts me right here. What else do I do? Where 3? Where? Which direction? That looks like left to me. Which direction do we move? In the positive direction, to the right. 3 units. Okay. So how do I write this in function notation? Negative f of x, then what? Minus 3. Perfect. Could you try... Oh, sorry. Could you try number 8, please? And check for stretch or compression using the same thing I showed you. Here is number 8. Is that what you got? Compressed by 1/2. Okay, this has a compression by 1/2. Remember, a stretch makes it like taller, kind of like when you're stretching a rubber band or maybe silly putty or slime or something. This compression looks like Play-Doh when you flatten it out. It looks like I kind of maybe sat on the dotted graph. If I look at the solid one, I go up 1 over 2, which is rise over run of 1/2. And if you look, yeah, it's half as tall as it was before. On the previous one that had the stretch, it was twice the height. Now it's half the height. Okay. And another way to think of it, if you remember what we wrote into our toolkit, 1/2 is greater than 0 because it's positive. It's not a reflection, but it's still less than 1, which tells me I have a compression. Okay. I don't want you to think of it as a fraction. The fraction tells me it's a compression. No, because I can give you 5 over 2. Is that a fraction? Yes or no? Is 5 over 2 a fraction? Yeah, but is that less than 1 or greater than 1? This is greater than 1. This is 2.5. So I don't want you to think, oh, fraction means compression, because if I put that, I won't. But if that was there, I don't want you to think, oh, that fraction automatically means a compression, because it doesn't, okay? Now we're going to work on number 9, and you're going to cross off number 10. We're not worrying about that one. We're not doing it. Okay, for number 9, though, so this graph right here, number 9, it's half a quadratic on its side. That's called a square root function. That's the graph of a square root. We're going to start them tomorrow. And then if I continued it in this direction, that's a cube root. Okay, so this is a square root graph. Number 10. So on number 9, what is one of the transformations that happens? Good. Reflect across the x-axis. What else happens? Do I have a reflection? Danielle says right 3 units. Do we agree with her? Okay. What else happens? And then down 2 units. Because it went there, then I go right 3, and now I have to go down 2 units. Now we're going to put that in an equation. So how do I write that as an equation? Negative f x minus 3 minus 2, like that. Okay, now we're skipping number 10, but I do have a question for you. From the dotted to the solid, what is happening? What is that translation? What's that transformation called? Reflection across the y-axis. Okay, you don't have to know that. We are only working on vertical transformations. That's a horizontal one, okay? Right now, I need you to please take out a piece of paper in a little bit. But first, you're going to take out a piece of paper. You're going to fold it into 4 and then number it 1 through 4. And you're going to work on this individually.